Last time we built the machinery, data split into partitions, executors running tasks, a driver handing out the work. So let us actually write our fraud job and run it. 5 lines. Read the swipes, join them to the merchant table so we know what kind of shop each one was, filter down to the last 30 days, group by card and count. Write the result out. You press run, and for about 2 seconds, nothing happens at all. No tasks, no activity on the cluster, nothing. Then everything happens at once, and when you look at what actually ran, it is not in the order you wrote it. 5 lines of code labeled read, join, filter, group, write, beside a cluster sitting completely idle with a clock ticking labeled nothing is happening. Here's why. Almost nothing you write in Spark actually does anything at the moment you write it. When you say, read this folder, Spark does not read the folder. When you say, join these 2 tables, nothing is joined. When you say, filter to the last 30 days, no row is examined. Every one of those instructions is simply written down. What you are building, line by line, is not a result, it is a recipe. A handwriting steps onto a recipe card labeled read, join, filter, group, with an empty kitchen behind it and nothing cooking. Instructions like read, filter, join, and group are called transformations, and they all behave this way. They add a step to the recipe and return immediately. You could write 200 of them in a row and your cluster would stay completely asleep. What woke it up was the last line, write the result out. That is a different kind of instruction called an action, and an action is a demand for an actual answer. Show me the rows. Count them, save them to disk. At that moment, and not before, Spark looks at the recipe it has been quietly accumulating and finally goes to work. A stack of recorded steps labeled transformations, recorded only, beside a single step labeled action, demands an answer, with the cluster waking up. So pause the video and ask the obvious question, because it is the right one. Why would anybody design it this way? Why not just do each step as it arrives? Waiting seems like pure delay. Look again at the order we wrote our job in. We read the swipes, then we joined them to the merchant table, then we filtered to the last 30 days. Think about what that means if you execute it literally. You would take 2 billion rows, join every single one of them against 50 million merchants, and only afterwards throw away everything older than 30 days. You would have done an enormous amount of work on rows you were always going to discard. Now, our storage holds about a year of history, so filtering to 30 days keeps roughly a 12th of it. If you filter first and only then join, you're joining a 12th as many rows. Same answer, a fraction of the work. And that is exactly what Spark does. It moves the filter to before the join, without being asked and without telling you. One thing to be precise about because it matters. Spark can only do that because our filter looks at a date on the swipe itself. It touches one side of the join and nothing else. If we had filtered on something from the merchant table instead, the filter could not move above the join because until the join happens, those columns are not there yet. Filters do not always move. Filters that depend on one side can. Now here's the point of the whole episode. It could only do that because it had not started yet. If Spark had obediently begun joining the moment you typed join, the opportunity would already be gone. You cannot go back and unjoin 2 billion rows. By waiting until you demanded an answer, it got to see every step you intended before committing to any of them and rearrange them freely. Laziness is not sloppiness or delay. It is what buys the right to optimize at all. Which has a consequence worth internalizing. You are not writing instructions, you are writing a description of what you want. Spark decides how. This is why 2 engineers can write the same job quite differently and get almost identical runtimes. It is also why staring at your code and trying to hand optimize the order of operations is often wasted effort. Something else is going to reorder it anyway. Now, that recipe has a shape. Each step depends on the ones before it. Reading produces something the filter consumes, the filter produces something the join consumes, and so on. So what Spark is really accumulating is a graph of steps, each pointing at what it needs. And notice one more thing about that graph. It goes in one direction only. Nothing ever loops back, which means Spark always knows, for any step, exactly which earlier steps produced its input. A one-way flow diagram of boxes reading read, then filter, then join, then group, then write, each arrow pointing forward only. That turns out to be worth more than optimization alone. If an executor dies partway through a job, and executors do die, Spark can look at the graph, see exactly which steps produced the lost partition, and recompute just that piece. It does not have to start your job again. It knows the lineage of every piece of data it holds. One executor going dark with a lost partition, and an arrow tracing back through the graph to recompute only that single piece. There is a catch, and it explains a bewildering experience most people have early on. Because nothing runs until an action, and because nothing is kept afterwards by default, calling two actions means running the whole recipe twice. Count the rows, then write them out. And you have just read and joined and filtered everything twice over. The fix is caching, telling Spark to hold on to an intermediate result. But caching has real costs and real ways of making things worse, so it gets its own episode later. A summary strip reading transformations record, then actions trigger, then the plan gets rearranged, then lineage enables recovery. But we glossed over something in the middle of all that, and it's the thing this whole series turns on. Spark happily moved our filter to before the join. It reordered our steps freely. So can it move anything, anywhere? It cannot. Some steps can be shuffled about almost at will. Others are immovable walls, and everything on one side has to finish before anything on the other can begin. And it is those walls, not your code, that determine whether your job takes 30 seconds or 25 minutes. Next time, the single most important thing to understand about Spark.